Hi, I'm Lorenzo Giraudi from Motion. Till now we spoke about cloud and libraries, but in this presentation we'll be talking about hardware for the edge. First of all, we are a small company in the north of Italy focusing on mobility solutions, engineering services, rapid prototyping, and small to mid-sized productions. Our core competencies goes from embedded software and e-mobility to engine control, simulation, test, and system-on-chip design. So, your application needs a board for running the edge part. Unlike the servers, edge devices are not so standard and have very specific constraints. For instance, each industry has specific interfaces, requirements, voltages, etc. The environment may not be friendly in terms of temperature, vibration, and dust. This imposes specific choices in the design. Also, safety might be requested to ensure the system is not a danger to the people. Finally, you need flexibility in terms of connections. So, from this, we developed the SDF platform, targeting mainly the automotive environment. It has a safe RX microcontroller from Infineon, and it is compatible with system-on-modules adhering to the open standard SMART that you can see on the top left corner. Our default solution is the i.MX8 Quad Max from NXP, with 6 64-bit ARM cores and GPUs as computing cores. This can run Linux with custom distribution compiled with the Yocto project. The mechanical design is fanless, relying on a passive cooling from the fins on the case. And finally, it integrates an Ethernet switch that supports time-sensitive networking standards. So the main benefits are that, of course, it can run containers, so you can easily run the AI toolkit you learned about before. Being Linux-based, you have a lot of pre-existing library and software available, like ROS, for instance. Having an on-board switch, it is easy to build, network, and plug all the needed peripherals to the board. Finally, you have two processors on the same board that can communicate together and exchange information. Because of this, the integration process gets easier thanks to the rugged design, and you will have all the needed interfaces. It is flexible, so in case you need different connectivity, it is enough to find a mini PCI Express module and add it to the board. You can even swap the processor to a different one. Linux is an open operating system, as you are well aware of. That means that you can customize it, and there are a lot of drivers already available. Last point, having a safe microcontroller means that it can act as an external watchdog plus a fallback solution if needed. So, compared to other solutions, our board has everything is needed to be integrated, can be mounted everywhere, has a wide input voltage range, and has specific interfaces. The on-board switch allows you to create reliable networks with other devices, and finally, it supports containers and thus the AI toolkit. Okay, this is a small part of our team, and I am the one on the left. My experience is mainly on hardware development, but I also have worked on the bring up of this platform. Here are my contact information if you want to write me, and there is also the link to both the teaching website and also to Ideas and Motion website if you want to learn about all the other stuff that we do. I think questions and discussion will be held at the final slot. So for the moment, thank you for your attention.